Okay, thank you for waiting. Hello everyone, good morning. My name is Noel. I lead the implementation team here at Solvexia. The topic of this webinar will focus on how we can make data aggregation, transformation, and validation easier. I'm going to start by talking about why data combining is difficult. Then I'll show you how we make this easier using Solvexia. I'll give you a quick demo of our automated solution, and finally allow some time for questions and comments you may have. With questions, please feel free to add them in the question box at any point during the presentation, and I'll get to them at the end. Let's get started. So the challenge of combining data. Many people need to combine data from lots of different sources in order to produce a report or do some analysis. This is challenging because the source files are often in different formats. As a result, people usually have messy and time-consuming processes in spreadsheets to combine, clean, and validate the data. This is not only waste time, it also makes it hard to scale. In fact, our recent study showed that around $140 billion a year are lost because of disconnected data, and is industry consensus that around 80% of the time goes into data preparation, whereas only 20% of the time goes into analysis, and that 80% of the time there is no value added to that. So we found that the need for combining data is not specific to a particular industry. Instead, this type of process takes shape in different industries and departments. Here are just a few examples we found over the years. So the first one is combining hotel booking data from different travel agencies, so the travel group can negotiate with hotels. So each of the agencies will have a different system that they use to book. So combining that data into a consistent and organized format is quite complex and time consuming. The second one is collecting claims from different brokers to calculate reinsurance payments at the group level. So each of the brokers usually uses a different system to collect the claims and premiums. So it's difficult to then aggregate and consolidate those into a common structure that can be used to calculate reinsurance at the group level. The third type is aggregating payroll data from different systems. So basically, in this case, there are different branches that manually prepare the timesheets that then are used to feed into the payroll system and prepare the pay slips. And because the files are manually prepared, they change from branch to branch, and they even can change from month to month. So it's quite time consuming to consolidate and transform those. Deconstructing the problem. So basically, we analyzed those problems and we found that they share components, and we think that there are three main components that can be clearly defined. So the first one is column alignment. So in this case, if you look at in the image here, the first row shows what we need. So basically, we need name, occupation, and amount. However, the input file that we have contains 4 columns, of which, for example, we don't need age. So what the user will need to do is delete that age column, and then things like amount and salary, they relate to the same, but they have different names. So basically, what we'll need to do is shift that salary column into just below amount. The second type of transformation the component we usually found is transformation. So in this case, for example, if we have a gender column and the system we are expecting to be either F or M, and we found some female, we will need to convert, or male, we will need to convert that to F or M. The third component we usually find, and oftentimes tend to be overlooked, is validations. For example, if we have an email field, we will expect to always have a NAT in each of the records, and if some of the records don't have it, we should flag, and then the user needs to decide what to do with that, either to fix it or, if it's not important, to ignore it. So those are the three main components. So going into a specific case study, we have Sally, and she's a payroll manager. So basically, she needs to combine data from different branches and each of the branches being a state in Australia. She needs to combine those files into a standard format that then she uploads into a payroll software to prepare the pay slips. So each of the files manually, as I mentioned before, each of the files is manually prepared by the branches. So they vary in the number of fields and in the structure of those fields. So the problem that Sally has is that she needs to manually prepare each of the files, and she will need to do things like transformation, column alignment, and then apply some validations to ensure that she's uploading the right files. So this process, and because the files can be quite large, this process tends to be slow, tedious, and is error prone. So it's not an ideal process for a person to be doing manually every month or every week. So let me show you an example of the files that she usually finds. So for example, if we look at New South Wales, it's a file that is quite structured. It's got some formatting, so it's quite easy to understand. But then we can have things like from Victoria, it's a bit more unstructured, different formats, so it's a bit more complex, and things like for Queensland, so it's completely different to the rest. So, and also if you look at the specific, at the data specific, looking at the employment type, you can see that, for example, for New South Wales, you will have full-time or part-time, so sorry, FT or PT for full-time and part-time, whereas for Victoria is going to be the full description, either full-time or part-time, and similar for Queensland. So basically what she needs to do is make sure that either everything is FT and PT or everything is full-time and part-time, but what you cannot have is both at the same time. So that's what she's got, and what she actually needs is basically two things. She needs an output that is consolidated, so everything is in the same structure, so the columns are in the same order, and the data is consistent across all the columns. So for example, the first column, you can see that it's branch, the second column is processing date, and so on. And what she also needs is she needs an exception report. And what that gives her is a list of the things that have been changed and a list of the things that are incorrect. So for example, things like email address doesn't contain an at. So that's what she needs. What we have done is create an automation solution to address this problem. So basically, the first thing we need is to, we start with the input files. So in this case, it's going to be the timesheets for each of the branches. And then we have a mapping and rule files. And I'll show you those ones later on. So we'll upload that into Solvexia. And then the first thing we need to do is consolidate the input files. So all the input files are going to be stuck one after the other. Next thing we need to do is mapping and field selection. So basically, using the mapping table, we are going to decide for each of, the user can define which fields from each of the files needs to be brought into the final output. The third thing we need to do is rules and validations. So here's when we do things like transformations or checking that the data is correct. Once that's done, what the system is going to produce is two outputs. So the first thing is going to be the consolidated output, and then a validations file that showing the things that have been changed, the things that is being excluded, and so on. So let me jump into Solvexia so I can show you the demo. So for those that are not familiar with Solvexia, this is the subscriber view. So this is what the user will see. First thing that the process asks for is a source data. So let me go into my files. So I have prepared here, I have a zip file with all the branches. So let me have a quick look at some of the files. So if I look at South Australia, I have employee name, employee surname in the first two columns, and then I have things like amount, date from, company, branch, and so on. Let me open another file so you can see the difference. So if I open South Australia, you can see that the format is different. So instead of employee name and surname being the first two columns, in this case, we have the company and the branch, and the employee is going to be column M and column M for South Australia. So each file is slightly different to the other. So we have those two files. Let me upload them into here. Then I need to provide my email. That's for notifications. Second thing we need to provide is what we call column alignment file and the data transformation rules. So let's start with the column alignment file. Let me open it. So this is the file. So if you look at this file, row number 2, so this one, basically this is what we need. So our system needs a branch, process date, employee name, and employee surname, and so on. So that's what we need. What we have, for example, for New South Wales is we have a file with extra fields that most of them we don't need. So for example, we don't need company, we don't map it. We have an office that in New South Wales they call it office, but it corresponds to the branch in our system. So we say, okay, if you find the office field, map it to branch. Similarly, if we look at Queensland, you can see that they call name and we need employment name. So basically we map name to employment name, and we do that for all the files that we need to work with. So in this case, we have 5 types of files: New South Wales, Queensland, South Australia, Victoria, and Western Australia. So that's going to be our file. Let me close this one. I upload this one here. The other file we'll need is the data transformation rules. Let me open that one. And this file contains 2 sheets. The first sheet is transformation, the second sheet is validations. Starting with transformations, looking at, for example, row number 2. So the rule ID is S1. The rule name is update employment type to show the full description. So in this case, this rule is going to be applied to the employment type field, and it's going to be applied when the employment type is equals to FT, and it's going to be converted to F full-time. So basically what this rule is saying is, okay, check all my files, check the column employment type, and if you find an FT, convert it to full-time. The rest of the rules do a similar kind of transformation. Looking at the validations, for example, if we look at the third row, so rule ID v2, in this case the rule name is called email address doesn't contain an at. It applies to the field email. The check type is not contains, the value is at, and the event is log and continue. So basically what this rule is saying is, okay, check my email field. If that field doesn't contain an at, I want it to be logged, but I wanted the process to continue. There are other options in case of errors. So there is also the possibility of fail. So for example, if we have if we're checking a field that is critical for this process and is incorrect, what we may want to do is the process to fail, so the user gets an alert and can fix the data. The second type is the one you just talked about, is log and continue, and the third one is exclude the record. This is in the case that, okay, you want to finish the process, you want to continue with your process, but that record is going to cost you issues in your system. So basically you want to exclude that record, perhaps do it manually. So that is going to what exclude record will allow you. Let me take it back to log and continue. Save. So I just uploaded my, just in case again, I uploaded my column alignment file, my data transformation rules, and now I have everything I need. So what I'm going to do now is click on import my data, and the process should start now. And for those that are not familiar with Solvexia, this is those are the steps that the process is processing. A green box means that the process has finished, that step 5 finished successfully. A blue one means that the step is currently running, and a gray one is meaning that it's waiting to run. And when it's finished, you can see that it generates two files. One called all branches that should contain the input file consolidated, and a validation file. So if I go ahead and download this one, save, open folder. So this file, let me do filtering here. So if I filter this file, you can see that it contains all the branches we process. So for example, let me pick 2 of them. So we have New South Wales here and Queensland here, and they have the same structure. Even though the files were different, the input files were different, the consolidated output put them into the correct structure. So this is the first file we have, and the second file is the validation file. Let me download another one. So the validation file contains 2 sheets. The first sheet is the validation sheet, which basically is is reporting all the things that have been changed. So for example, let me move this here. If you look at row number 2, it's telling you that this record didn't contain the email address for this record didn't contain an ad, so it locked that record and continue, didn't do anything similarly for the rest of the records. So the second sheet we have is the control, and what this sheet does is show the user first thing the input files that were in our zip. So it's saying we have 5 input files, the number of records in each of the files, and then the same for the output. So the consolidated output has these branches, and these are the number of records, and you can see that they are equal. So basically everything that went in is coming out. If we had in our data transformation file, if we have added some exclusions, and there happen to be records that need to be excluded, you will see that the number of records is different. So basically what you will need to do is reconcile this plus exclusions should be equal to this. But in this case, because there were no exclusions, the numbers match perfectly. So this is in the case of the process just finished and the user could use the consolidated file. Now I would like to show you what happens if a new branch is added. So what I've done is I added a new branch, Tasmania here. Let me open the file and show you. So basically, this is a new branch, and they need to add that to the process. So the thing I need to do, first thing I need to do is I open the file, and then I need to go to my column alignment file. Copy the headers and put them into one of the placeholders here. Oops, let me paste with format. Cool. And let me call this one Tasmania. So what I need to do now is I need to map each of the fields for Tasmania to what we need. So for example, employee name, surname name, they look like this is what we need. Email, this should be this one. Let me make this a bit bigger so I can see better. Employment type should correspond to this. Those 3 should go here. Account number should go here, and then branch and processing date, those 2 should go here. So we just map a new type of file. Let me save that. This file. And something that you may notice is that for the branches, we've been using three-letter characters. So instead of Tasmania, we would like to have TIS. So what we need to do now is in our data transformation rules, we can add an extra rule to deal with that. So basically, if we go and say, okay, let's call it update branch for Tasmania. So in this case, we want to apply that to the branch field. We want to do it when the branch is equals to Tasmania. And we want that value to be TIS. So basically what I'm trying to do is I want to replace this with TIS. Let me save this. And one of the things with this process is that once you define the columns, it doesn't matter the order. So if you know that you have 10 columns and those are the names of the columns, what you could do is you could shuffle them around. So I could do something like this. Over here, maybe this one over here. Oops, something like this. Let me do it again. So something like this. I still have the same number of columns, but they are in a different order. Save it to my new branch. Put new branch. Zip all of them together. Let's call it new branch. So basically what I need to do now is I need to create another run. I will need to upload my new branch. Click next. I will need to upload my updated alignment file, my updated data transformation rules, and click import data. So now what the system is going to do is add that extra input file into the consolidated output. So it's going to add Tasmania to the final output, and it's going to convert the branch from Tasmania to TAS. So the process, as before, it should take around 30 seconds, and when it finishes, it should we should have two output files. So yeah, that's finished. Let me open that one. So if I open the all branches, let me filter this. Yeah, and you can see that Tasmania is here. So we have 302 records for Tasmania, and the branch is not Tasmania, it's TAS. So if I, for comparison, if I open the file, what I should be expecting is my first record in that file is Moina, this one. So basically, yeah, so what the process done is employee name, column A, is being mapped to column C. Employee type is being mapped to column E, and you can see that the transformation full-time has been applied. And for branch, column P is being mapped to column A, and also transformation Tasmania has been applied. So it went from Tasmania to TAS. Now, let me close all of this. Let me download the validation file. And what I should be expecting this validation file is in the control sheet, I should have an extra file. Yes, so I have an extra file, which is Tasmania, and it's telling me that we imported 302 records and that we have 302 records in the output file. And that's all for my demo. Let me go back into the presentation. So the summary, what we done in Solvexia. So basically what we've done is we create a process that is simple, or we think that is simple and rules driven. So basically there is no need for the user to manually make changes. Everything is controlled by either the alignment file or the data transformation file. It's flexible, so it allows you to upload a variable number of files. Input files, you just need to zip them into a file and upload into Solvexia. It can be 10, 20 files, whatever you need. And it's scalable, so it's very easy to keep on adding new file structures or keep on adding rules. So new transformations, new validations is very easy because everything is controlled through those two files. So let's jump into questions. Let me open the question panel and see the questions you have. So I have a question here. Hi Noel, in the data transformation file, we can put in conditional formula or a little more complex rather than the kind of hard coding that has been done in Caroline, such as in the current file, such as Tasmania. Yes, so basically for the demo, I tried to keep it quite simple so the formulas are simpler. But yes, you could, because basically what we're applying the changes is using SQL, so you could do any kind of formula in SQL. You could do things like replace, you could do combinations across multiple fields, so you could multiply one file times the other, or you do the combinations. Yeah, you can do pretty much everything you want. I hope that answers your question. The second question I have is, hi Noel, can we create and maintain different rules ourselves? Yes, you can create. Yeah, basically that's the idea. The idea is that the end user should be able to keep on adding rules and maintaining those rules. And because the process is quite quick, you should be able to have a quick feedback. So you could add the rule, run the process, see what happens, and if you don't like, change the rule and run the process again. Any other questions? So the next question is, what type of files can be processed? So basically, any type of file that is a text file. So it could be things like CSV, TXT, flat files. You could add Excel files. So yeah, it's completely open to the user. Let me see. Next question is, how many files can be aggregated at once? So I think I mentioned that before. There is no defined number, so you can add as many files as you want. Obviously, the more files and the larger the files are, the more time the process is going to take, but there's no hard limit to that. Say, next question is, what happens if I upload a file with a format that is not in my alignment file? So basically, if you upload a file that with a different format to what you have defined in your alignment file, the process is going to run, but that file is going to be ignored. And at the end of the process, you're going to receive an email or an alert saying, okay, we find this type of file that we couldn't map to anything. So then it's your choice to either run the process for that file, or so add that file to the mapping, to the alignment file, and run the process just for that file or for all the files together. I think, yeah, I have another one. My last question is it easy to connect to other systems like General Ledger or Data Warehouse? Yes, the answer is yes. In that case, basically, we have an API that allows the process to connect to different sources. So basically, if you have a data warehouse where you store your data, from this process, we could have an API call that goes to your system, fetches the data, runs the process, consolidates the data, and then pushes it back using the API to your system. So let me check if we have any other questions. No, we don't have any other questions. So yeah, thank you for taking the time to join this webinar. I hope you found it useful. And yeah, and please let me know if you have any process for combining data that you think can be automated. I'll love to hear from you. Thanks and bye. Thank you.